The temperature readout on my LiDAR console said 36.6 degrees Celsius the moment we crossed within 50,000 kilometers of Tartarus, and instead of calling it what it was, a sensor malfunction, a calibration error, a cosmic joke, I restarted the thermal array and logged it as instrument noise, because that is what the data told me to do, and I have always trusted the data. My name is Dr. Harris Locke, and I have been mapping dead rocks for 11 years. The Kepler 200 was not built for comfort. She was built for precision. A survey vessel stripped of everything that did not directly feed information into her sensor arrays, which meant the crew quarters smelled permanently of burned coffee and the ozone tang of overworked electronics, and the walls hummed with the vibration of cooling fans running at maximum capacity because we were pushing every instrument we had into the dark ahead of us. Mission Commander Yeva Sorel had given the order 3 hours ago. Full spectrum sweep. Whatever was out there, she wanted it mapped before we put anyone on the surface. There was no surface visible. That was the first thing that struck you, even before the numbers started lying. I had mapped Ceres. I had mapped Sedna. I had spent 4 months charting the irregular face of 2014 UZ-224, a dwarf planet so lumpen and asymmetrical that my model kept crashing because the processing cores refused to believe something that ugly could be a gravitationally stable body. I knew what deep space objects looked like on approach, the way starlight bent around their edges, the way they interrupted the background field, the faint albedo signatures that told you what you were dealing with before you ever ran a single scan. Tartarus interrupted nothing. It absorbed everything. Our forward floodlights, 4 arrays rated at 1200 lumens each, hit its surface and vanished. Not reflected, not scattered, simply gone, the way sound goes when you shout into a room packed floor to ceiling with acoustic foam. The object swallowed light the way a body swallows air. Completely, without remainder. What we could see existed only on the monitors. The infrared composite showed a sphere. Not approximately spherical, not the potato-shaped lumps most bodies this far out turned into after billions of years of collisions and tidal stress. A sphere, the kind of sphere you drew in geometry class with a compass. The kind that made my calibration software throw a warning because objects of this diameter were not supposed to be this round, and my software had been programmed by people who understood the physical limits of gravitational compression. Whatever force had shaped Tartarus, it had not been gravity alone. Commander Sorel leaned over my station. "Give me a composition estimate." "Working on it." I pulled the thermal data back up, stared at the number. 36.6. I need to recalibrate the thermals first. I'm getting a contaminated reading. How contaminated? It's showing uniform surface temperature across the entire object. Body temperature warm. She straightened. Body temperature. Instrument artifact. The background radiation from the cooling manifolds is probably bouncing off the hull plating and feeding into the sensor array. I've seen it happen on long-haul missions before. I had seen it happen exactly once, on a 3-year survey run in the asteroid belt, and the contamination then had been localized, not global. But I restarted the array and moved on, because the alternative hypothesis was not one I was equipped to process at 11:30 in the morning on my second cup of terrible coffee. The recalibrated thermal array came back online. The reading was 36.6 degrees Celsius. I moved to the LiDAR panel and began the primary scan. The system fired its first pulse sequence at 0911 hours local ship time. The lasers went out, found the surface at the expected range, and began returning data. Good data, clean data, the kind of crisp return signal you got from hard matter, not gas or ice. Whatever Tartarus was made of, it was dense, and its surface was solid. My processing core began stitching the returns together into a preliminary topographic model, and I watched the map build itself in real time on the central display. I had been expecting craters. Impact history was the first thing you read in any rocky body's surface. The record of everything that had hit it over 4.5 billion years. Every collision preserved in the geology like a sentence pressed into wet clay. A body this size and this far out should have been cratered into near chaos, its surface a palimpsest of overlapping impacts stretching back to the solar system's formation. Instead, the LiDAR was drawing lines. Not random lines, not fault scarps or lava flow channels, or the irregular ridges you got from tectonic activity on geologically active worlds. These lines intersected at precise angles, branched into smaller lines that branched again into smaller lines still, each subdivision maintaining the same angular relationships as the one above it, the pattern repeating at every scale the sensor could resolve. At the 10,000 kilometer level, it looked like a geometric lattice. At the 100 kilometer level, it looked like the same geometric lattice. At the 10 kilometer level, still the same structure, still the same angles, still the same relentless mathematical precision. I knew what I was looking at. Every scientist knew the word, even if most of us had never expected to encounter it outside a textbook. Fractal. Commander. My voice came out steadier than it had any right to. I need you to see something. Sorrel was at my side in 4 seconds. She looked at the model building itself on the display. She said nothing for a long time. That's not natural, said Dr. Maren Foss, our geologist, from the station to my left. She had been watching over my shoulder for the last 20 minutes. No natural process produces fractal geometry at that scale. Not erosion, not volcanism, not crystalline growth. Not at this size. We don't know what processes operate at this distance from the sun, I said, because it was the scientifically responsible thing to say, and because I needed to say something that pushed the other explanation back a little further. Harris. Foss's voice was quiet. That pattern repeats across 8 orders of magnitude. 8. We've been looking at surfaces for 50 years, and we have never seen anything like this. I looked at the model. The model looked back at me with its perfect, inexplicable geometry, its lines branching and branching and branching into the dark. I'm going to run a boundary analysis, I said. I want to find where the pattern terminates. I ran the boundary analysis. The pattern did not terminate. At every scale we could resolve, from the maximum range of the sensor array down to the minimum detectable feature size of approximately 3 meters, the fractal structure was present and consistent. I expanded the scan to cover 60% of the visible hemisphere. Same result. I pushed the sensor gain to maximum and started hunting for irregularities, for places where the pattern broke down, for the seams or joints or discontinuities that would tell me this was a constructed thing with edges. Nothing. The geometry ran to the horizon in every direction, seamless and eternal and absolutely precise. It was Foss who said it first, in a voice that was almost completely calm. We need to report this. Not yet, said Sorrel. Commander, not until we know what we're reporting. Sorrel's eyes had not left the display. If we call this in as an artifact without confirmation, every government agency in the solar system is going to be parked on our doorstep within 18 months. I want solid data first. Harris, I want depth. Can you get me internal structure? The gravimetric tomograph can give us rough density layers, I said. It won't be high resolution, not at this range, but it'll tell us if the structure goes below the surface. Do it. I activated the gravimetric array and began the deep scan sequence. The system was designed for probing the internal structure of rocky bodies, mapping density variations that indicated or deposits or cavitation. Practical information for the mining surveys that were the ostensible purpose of most deep space cartography missions. It was not designed for objects this large. The processing load was substantial, and the computer labored visibly, its cycle indicators climbing toward the red as it tried to integrate the incoming data. While the gravimetric scan ran, I went back to the LiDAR returns and began looking at the timing data more carefully. This was the kind of thing I did when I needed to feel competent. Pull the raw numbers, look for patterns, exercise the part of my brain that knew how to make sense of measurements. The timing data told you how far the surface was at any given point. Consistent timing meant a stable surface. Variations in timing meant topographic relief, which the fractal pattern had already told us was substantial. What the timing data was not supposed to show was drift. I flagged the first anomaly at 1,034 hours. The return time for a cluster of pulses in the northern polar region had increased by a small amount. Small enough that on a routine scan I would have attributed it to atmospheric lensing or instrument jitter and moved on. But there was no atmosphere here, and my instruments did not jitter because I calibrated them myself and I was very good at my job. I pulled a second cluster from the equatorial region. Same drift, same direction, same magnitude. I pulled a third cluster from the southern hemisphere. Identical. The surface was moving away from us. Not catastrophically, not at a speed that any casual observer would have noticed. The displacement was measured in meters, not kilometers, and it was happening slowly enough that I had to stack multiple return sequences on top of each other and subtract the baseline to be certain it was real. But it was real. My instruments did not lie. I inverted the data set, pulled the sequence that had preceded the increase. Before the surface moved away from us, it had moved toward us by exactly the same amount. I sat with that for a moment. Then I pulled the full timing record back to the beginning of the scan and graphed it. The line on my screen described a gentle, regular sine wave. Surface displacement, plus or minus 4 meters. Period, 40 seconds. The curve was smooth, unhurried, and absolutely consistent. Something that large was rising and falling 4 meters every 40 seconds. I put my hands flat on the console. I did not call for Sorrel. I sat there and I looked at the graph, and I did the only thing I knew how to do with data, which was try to find an explanation that fit the numbers. Tidal stress. But there was nothing large enough nearby to generate tidal stress at this amplitude. Seismic activity. But seismic events were episodic and variable, not rhythmic. Thermal expansion. Conceivable in principle, but not at this regularity, not without an energy source I could identify. I kept coming back to the one explanation I was not going to write in my log. The gravimetric scan completed at 1,047 hours with a sound like a large computer giving up. The processing cores had been running at maximum load for 13 minutes and had managed to assemble a density profile that extended approximately 400 kilometers below the surface. I pulled the visualization up on the secondary display. The fractal structure went down. It went down 400 kilometers into the body of Tartarus, which was the maximum depth the gravimetric tomograph could resolve at this range, and at every depth layer the structure was present, consistent, and identical to what we had seen on the surface. There was no core, not a differentiated core, not the dense metallic center you would expect in a rocky body this size after billions of years of separation under gravity. There was only the fractal geometry, repeated at every depth, all the way to the limit of what I could see. It goes all the way down, I said. Foss had already seen it. She was standing very still. What does it mean? Said Navigator-Core from the far end of the bridge. He was the youngest member of the crew and the only one who had not yet learned to modulate his voice when the situation called for it. It means, said Foss slowly, that whatever this structure is, it is not a shell. It is not a constructed object with an interior. It is solid all the way through, and the pattern that covers its surface continues into its interior without interruption. What has that kind of internal structure? Core asked. No one answered him. I looked at the thermal reading, still sitting in the corner of my primary display where I had been ignoring it for the last 2 hours. 36.6 degrees Celsius. Body temperature. Consistent across the entire surface, from pole to pole, from the deep cold of open space that should have been pulling heat away from any exposed surface at a rate I could calculate precisely, into an environment that registered 2.7 Kelvin at background, with no internal energy source we had detected to compensate for the loss. The heat was not being lost. Whatever Tartarus was made of, it was maintaining its own temperature against the void, generating heat from within and distributing it uniformly across a surface area I had measured at 7.9 times 10 to the 16th square meters, which was larger than Neptune, which was itself a planet, which was itself a thing I had told myself twice in the last 3 hours and had still not fully processed. 36.6 degrees. The number had a specific significance that I was not going to articulate even inside my own head, because articulating it would mean accepting it, and accepting it would mean I needed to completely restructure my understanding of what we were doing out here. I pulled up the sine wave graph again. For meters, 40 seconds, up and down and up and down and up and down, as regular as a clock, as patient as something that had been doing this for longer than the human species had existed. The thought arrived without permission. If you removed scale from the equation, if you ignored the fact that we were talking about a body the size of a gas giant, the motion I was looking at was not geophysical. It was respiratory. Commander. I kept my voice flat, professional, the voice I used when I was delivering data. I need to show you something. Sorrel came and stood at my shoulder, and I walked her through it. The sine wave, the period, the amplitude, the thermal data, the fractal structure extending through the full depth of the scan. She listened without interrupting. When I finished, she was quiet for a long time. "You're not saying what I think you're saying," she said. "I'm showing you the data," I said. "I'm not saying anything." Harris. The data is internally consistent. All of it fits together. I cannot find an error in the measurements. I took a breath. I've been running this equipment for 11 years. I know what instrument artifact looks like. I know what calibration failure looks like. I know what contaminated data looks like. This is none of those things. Another silence. Foss had moved to stand beside us. She had seen everything I had shown Sorrel, and she had not said a word. "The structure on the surface," Sorrel said finally. "The fractal pattern." "Yes. You said it repeats at every scale down to 3 meters. That's the minimum resolution of the LiDAR at this range." "Yes." Sorrel turned to look at me. What would the pattern look like at a smaller scale? If it kept going? I had not let myself think about that. "I don't know." "Guess." I looked at the model on the screen. The branching lines. The perfect repetition. The mathematics of it, which was the mathematics of biological systems, of lungs and blood vessels, and the branching structures of neurons, the way living things solve the problem of moving material through three-dimensional space efficiently. My colleague at the University of Edinburgh had spent 20 years studying the fractal geometry of organic tissue and had published a paper arguing that fractal self-similarity was the universal solution to that problem, that any sufficiently complex biological system would converge on it regardless of its origin. "It would look like tissue," I said. No one spoke. I pulled up the thermal map one more time, rotated it, applied a false color scale to emphasize the temperature gradients, which were almost non-existent. The temperature was so uniform, so perfectly distributed, that the gradients were measured in thousandths of a degree. The kind of uniformity you could only achieve with an active circulatory system. Then I looked at the LiDAR composite. The fractal lines on the surface, branching at their smallest visible scale into features that were, at the resolution limit of my instruments, approximately the diameter of a human hair, if the features were being observed from several hundred kilometers away, which meant their actual scale was something I would need to calculate properly, something I had been avoiding calculating because I did not want to know the answer. I calculated it. The smallest visible features on the surface of Tartarus were approximately 300 meters across. If the fractal pattern continued below the resolution limit of my instruments, the next subdivision would be in the range of 30 meters. The one after that, 3 meters. The one after that, 30 centimeters. The Kepler 200 was 40 meters long. I had been firing lasers at this surface for 6 hours. High-powered survey lasers, calibrated for maximum penetration, designed to punch through rock and ice and return clean signals from depth. I had been using them continuously, at full power, sweeping them systematically across the surface in overlapping grids, doing exactly what I was trained to do and exactly what the mission required. I had not been scanning a planet. The realization did not arrive all at once. It came in pieces, each piece connecting to the last, the way a map assembled itself from individual survey returns. First the outline, then the detail, then the full picture, which was always larger than you had imagined from any single vantage point. An object the size of Neptune, maintaining its own body temperature against absolute zero, displaying rhythmic surface displacement consistent with respiration, covered in fractal geometry identical to biological tissue structure, with no differentiated core, its internal architecture consistent at every depth with a living material rather than a geological one. We had not found Planet 9. We had found something that had been here, in the dark, at the edge of everything, for longer than the sun had been burning, doing the one thing that all living things did when the environment was hostile and resources were scarce. It had been sleeping. The LiDAR alarms activated at 1,203 hours. Not the soft advisory chimes that indicated data anomalies or sensor saturation. The hard alarm. The one that pulled you out of whatever you were doing and demanded your full attention. I had heard it exactly twice in 11 years, both times during equipment failures. I looked at the display. The fractal structure was changing. The lines on the surface model, those perfect, regular, branching geometries that had been static since the first moment I had resolved them, were moving. Not all of them. The change was localized, beginning at a point approximately 800 kilometers southwest of the area I had been scanning most intensively, where I had spent the most time with the lasers at maximum power, doing the most thorough survey work, building the most detailed section of my map. The smallest scale features were dilating. I had been looking at this surface for 6 hours. I knew its geometry the way I knew my own instruments. What I was seeing now was not data noise, not sensor artifact, not calibration drift. The structures on the surface of Tartarus, the structures I had been persistently, methodically illuminating with high-powered laser pulses for the better part of a working day, were opening. "Commander." My voice was steady. This was the voice I used for emergency data deliveries. Full reverse thrust. Now, Sorrel was at my side in 3 steps. She looked at the display. I watched her read the same thing I had read. "Dash," she said, with the same flat professionalism I had used. "I'll stop." Full reverse. "Execute." The Kepler 200 shuddered as the main drives fired against our approach vector. The ship groaned in a way I had not heard before. Not a mechanical sound, but something deeper, something that came through the hull as vibration rather than noise. The thermal alert activated while we were still processing the LiDAR change. Not the standard temperature variance alarm, the critical alarm, the red band alarm, the one connected to the systems that monitored hull integrity. The external temperature reading was climbing, not from 36.6 degrees, from higher than that, from much higher, the sensor pegging its scale and throwing an overflow error because the number it was trying to report exceeded the range it had been calibrated for. The vent on the surface was now visible even on the infrared composite, and it was not small. From a range of 40,000 kilometers, my instruments were resolving a feature that had not been present 40 minutes ago. A line, running for a distance my ranging software estimated at 11,000 kilometers, from which heat was escaping in quantities that pushed my flux calculations into ranges I had to verify 3 times because the answer they kept returning seemed impossible. The heat signature was the color of something alive. The gas expanding into the vacuum around it formed a cloud that my spectroscopic sensors were already interrogating, and the results were coming back wrong in ways that did not make sense for a geological outgassing event. I looked at the thermal map. The fractal geometry of the surface was reorganizing itself around the vent. The smaller features, those 300-meter structures I had resolved at the limit of my instruments, were not just dilating near the survey site. They were dilating in a widening radius. The pattern was propagating outward from the point of maximum laser exposure, moving across the surface in a wave that my tracking software was estimating at approximately 2 kilometers per minute. The sine wave that had been my 40-second respiratory cycle was no longer 40 seconds. The new period, which my instruments had updated 3 times in the last 4 minutes, was 37 seconds, then 34, then 31. The rate was increasing. Outside the viewport, there was nothing to see. There had never been anything to see. The object ahead of us was still perfectly, absolutely dark, still swallowing every photon our floodlights threw at it, still invisible to every human sense in the way that only something truly immense could be invisible, not because it was small or distant or faint, but because it was so large that it had become the background, the context. The thing your eyes refused to resolve as an object because it was simply everywhere you looked. But in the lower right corner of the viewport, where the edge of Tartarus met the open field of stars behind it, something was changing. I had to look at it for a long time before I understood what I was seeing. The stars at the edge were moving. Not moving the way stars moved when the ship rotated, not the smooth apparent drift of navigation. Moving in a specific direction, at a specific rate, in a specific arc, as if the edge of the object itself, that absolute, light-consuming boundary, was curving differently than it had been before. The object was changing shape, not dramatically, not visibly, not at a scale any human eye would catch without a reference frame. But I had a reference frame. I had the topographic model I had been building for 6 hours, and I had the ranging data that had been feeding into it continuously. And when I overlaid the current ranging returns on my model from 2 hours ago, the discrepancy was real and measurable and impossible to attribute to instrument error. The curvature of the surface had decreased, imperceptibly, fractionally, but the change was consistent across every ranging point I had data for, and it was in the same direction at every point. The surface was becoming less spherical. The radius of curvature was increasing. Something that had been curled into a sphere for longer than I could meaningfully imagine was beginning to uncurl. The gas cloud expanding from the vent site had now grown large enough that my spectrometer could resolve it clearly. The composition results finished processing and appeared on my secondary display, and I read them once, and then I read them again, and then I set the results aside in the part of my brain where I was storing the things I was not going to fully process until later, because processing them now would have interfered with my ability to function. The gas was organic, not in trace amounts, not contaminated with organics the way comets were contaminated, the way asteroids carried the occasional amino acid as a relic of presolar chemistry. Massively, overwhelmingly, compositionally organic. The complex molecular signatures of biological processes at temperatures that should not have been possible out here, at pressures that implied an interior environment nothing like open space, nothing like any planetary body I had ever studied. The biological heat was escaping through the opening. Sorrel was standing at the center of the bridge, looking at the main display, and she had not spoken in 4 minutes. None of us had spoken. The ship's drives were running at full reverse, and we were pulling away from Tartarus at a rate that would have seemed substantial in any other context. But Tartarus was large, and the distances involved were large, and the math on how quickly we could reach a separation that felt meaningful was not comforting. I looked at the sine wave monitor. 28 seconds. The new respiratory period was 28 seconds. The wave itself was larger now, the amplitude I had measured at 4 meters having expanded to something the system was currently estimating at 22 meters and recalculating upward every 30 seconds. Something that had been breathing at rest was breathing faster. On the main display, the topographic model of Tartarus, 6 hours of careful, precise survey work, the most detailed map of an unknown body I had ever produced, was becoming obsolete in real time. The model I had built assumed a static surface. The surface was no longer static. The fractal pattern was reorganizing itself across the entire visible hemisphere. The geometry, shifting in ways that my change detection algorithm was flagging with more red indicators than I had ever seen on a single display. The shape of the thing was changing. Slowly, the way very large things changed, the way continents drifted, the way glaciers moved, but changing, and the change was directional, and the direction was outward. I sat in front of my console, and I looked at 6 hours of work becoming a historical record. The most important survey of any object in human history, and it was already out of date. There was a glow in the viewport, not the glow of stars, which I could have told you from memory, which I had been looking at for 11 years and knew the way you knew your own handwriting. Something else. Something that came from below, from the surface, from that vent that was now 11,000 kilometers long and growing, from whatever was inside Tartarus that had been sealed away from the cold for longer than the solar system had been a solar system. Biological light. Not the clean, white, physics-governed light of a star or a floodlight. Something diffuse and yellowish and warm, the color of heat seen through skin, the color of a living thing from the inside. It came in a line, a long, curved line that followed the vent site, and it painted the underside of the expanding gas cloud in a color that had no business being this far from the sun. The drive vibration changed frequency, not in a way that indicated mechanical problems, in a way that indicated something external was affecting the hull. I checked the gravimetric sensors and found them saturated, the output pegged at maximum reading, which meant the gravitational environment around the ship had exceeded the instrument's calibrated range. The thing was not just changing shape, it was moving. I sat with my hands on the console and I watched the viewport, and I tried to think about what data I still needed to collect, because that was the professional question. That was the question a cartographer asked. That was the one thing I knew how to do when everything else stopped making sense. What data? What measurements? What information would be most valuable to the people who would read my log and try to understand what had happened out here? On the display to my right, the critical temperature alert was pulsing. The gas cloud from the vent had expanded far enough that the outer edge of it was reaching our range, and the temperature differential between the gas and the background vacuum was registering on the hull sensors. Not dangerous yet. Getting there. On the display directly in front of me, the topographic model continued its automated update cycle, pulling in new ranging data and trying to reconcile it with the accumulated model. It was flagging conflicts every few seconds now. The surface it was measuring no longer matched the surface it had mapped. The algorithm kept trying to identify the discrepancy as instrument error, which was the default assumption when reality conflicted with the model, and I kept overriding it, telling the system that the new data was correct and the old model was wrong, that the ground had moved, that the map was obsolete. The glow in the viewport grew. Not quickly, not dramatically. The way dawn grew, the way light returned after a long absence. Gradual and undeniable. The first evidence of a source that was still too far away to see directly, but was already large enough to change the quality of everything else. The stars at the edge of Tartarus were no longer being occluded by a smooth curve. The edge was irregular now, in a way I could see without instruments, with my own eyes, and the irregularity had a shape that I recognized from the maps I had spent the last 6 hours building. The fractal structure, visible with the naked eye, not as lines, as movement, as the organized, purposeful reorganization of a surface that had been still for longer than I could meaningfully calculate, responding to something, to temperature change, to chemical signal, to whatever mechanism a living thing used to rouse itself from a sleep that deep, with the slow, massive, unstoppable momentum of an object that had gravity on its side. I was still recording. All the instruments were still running, still collecting, still building the database of the most significant contact event in the history of biological science, in the history of any science, in the history of the species that had sent this ship out here to map a rock. The last thing I logged, at 1,247 hours, was a note in the survey record. The object designated Tartarus has revised its classification. It is not a planetary body. It is not a geological formation. It is not an artifact of any civilization we have cataloged or hypothesized. The appropriate category for this object does not exist in our classification system, because our classification system was built on the assumption that the largest living things in the universe were things like whales or sequoias, or the mycelial networks that could cover a few hundred acres of forest floor if given enough time and nutrients. Nobody had classified the thing that the mycelium thought it was crawling on. The glow through the viewport was now bright enough to cast shadows inside the bridge. The gas cloud around us was warm. The drives were pulling us away from Tartarus at maximum sustainable acceleration, and Tartarus was. I checked the ranging data one more time, because I was a cartographer and I did not stop measuring. Still there, still filling a solid angle of space that my instruments measured at 43 degrees, which was larger than it had been 20 minutes ago, not smaller. We were moving away from it. It was getting bigger. The vent line was the length of a continent, and it was still opening. And what was inside was alive, and it was warm, and it was very, very old, and it had just been poked 11,000 times with a needle. And now it was waking up, and I was watching the first light it had released into the universe in longer than I had numbers for. My survey log showed 847 gigabytes of the most precise topographic data ever collected on any body in the solar system. Maps of something's skin. The light kept growing.